Take a deep breath. The world beyond your walls begins to fade. The weight of the day, the hum of thought, the rhythm of movement, all of it softens until only quiet remains. Now imagine yourself lying beneath a sky so wide it has no edge. Above you hangs a pale lantern of stone and light, the moon. It has always been there, long before the first words, before fire, before memory. That same silver face watched over the newborn earth. It has seen continents shift, oceans rise, and the slow unfolding of life. For as long as minds have looked upward, they have found comfort in its glow. A light that does not burn, but soothes. A presence that turns the darkness gentle. Tonight, we drift backward through time to meet it at the moment of its birth. When the heavens were chaos and fire, we will travel through the storms of creation, the cooling of stone, the shaping of craters and plains, and the slow settling of light into rhythm. We will follow the moon through its long companionship with Earth, its pull on the seas, its reflection in our myths, its whisper in the tides of our sleep. Let your breath match the turning of the world, in and out, like the quiet pull of gravity between two bodies that have always known each other. The same force that moves oceans moves you. The night waits, patient and infinite. Let's begin. 4.5 billion years ago, the Earth was young and violent. Its crust was a skin of molten rock, its air thick with carbon and steam. Volcanoes raged across its surface. Lightning flashed through a red haze, and meteors still rained from the formation of the solar system. There was no blue, no water, no calm, only heat and chaos. Then, somewhere beyond the newborn orbits of Mars and Venus, a wandering body approached. It was roughly the size of Mars, a planet we now call Theia. Its path curved inward, drawn by Earth's gravity until, at a shallow angle, the two worlds collided. The impact melted the surface of both. Mountains vaporized. Oceans of magma erupted into space. For a moment, brighter than any sunrise, the Earth became a sphere of liquid light. The collision tore billions of tons of rock into orbit, a glowing ring of molten fragments circling the wounded planet. The temperature soared beyond 4000 degrees C. The sky filled with fire. But even in that devastation, gravity began to work. Slowly, patiently, it gathered the fragments together, fusing them into a single spinning sphere. Over a few thousand years, a heartbeat in cosmic time, that sphere cooled and hardened. That body became the moon. Born of destruction, would bring stability. The violent birth created a perfect balance. The moon's gravity slowed the Earth's rotation, steadied its tilt, and laid the groundwork for calm seas and gentle seasons. Out of chaos came rhythm. Out of fire came the first quiet night. In the aftermath of the impact, Earth glowed red-hot beneath a haze of vaporized rock. Around it spun a halo of molten debris, orbiting faster than any cloud, brighter than any sunset. From the surface, had anyone been there to see, it would have looked like a band of liquid fire arching across the sky. That ring did not last long. Gravity pulled its fragments together, their collisions forming clumps that merged and melted again. The newborn moon grew inside that halo, its gravity sweeping up the last of the fragments until the sky cleared. The distance between Earth and Moon was then only about 25,000 kilometers, 10 times closer than today. So close that the moon filled half the horizon. Tides hundreds of meters high swept the young oceans, reshaping the coastlines every few hours. The new world cooled quickly in space. Without atmosphere or weather, its heat escaped directly into the void. Volcanic activity remained fierce for millions of years. Rivers of lava rolled across the surface, pooling in deep basins. When the last of that molten ocean solidified, the surface was sealed forever. Every later impact would leave its mark. Unlike Earth, the moon had no rain, no wind, no plate tectonics. to erase the past. It would remember everything. As the lava plains cooled, they hardened into the dark regions we now call Maria, Latin for seas. They are not seas of water, but of rock, basalt frozen from ancient eruptions. The great Mare Imbrium, the Sea of Tranquility, the Sea of Serenity, names that humans would give billions of years later, were once glowing lakes of liquid stone. Between them rose lighter highlands, made of anorthosite, a rock rich in calcium and aluminum, bright enough to reflect sunlight like snow. Geologists divide the moon's history into eras. The pre-Nectarian, when colossal impacts carved the first basins. The Nectarian, when the crust solidified. The Imbrian, when lava filled the great basins. And the Copernican, our current epoch, when fresh craters like Tycho and Copernicus were born. Each era left signatures in the dust, glass beads from impacts, microscopic crystals forged in heat and frozen in time. As the Earth cooled below, oceans condensed from its thick atmosphere, clouds formed, rain fell for the first time. The tides, enormous and relentless, pulled by the nearby moon, stirred the newborn seas. That motion mixed minerals, heat, and light, the ingredients of chemistry that would, much later, awaken into life. The nights were luminous. The moon, 10 times brighter than now, hung close enough to cast moving shadows as it orbited. To that young world, it was both guardian and sculptor. Its gravity shaped the waters. Its glow defined the first rhythm of day and night. Over hundreds of millions of years, the moon drifted outward. As its distance increased, the tides calmed, and Earth's rotation slowed to the familiar 24-hour day. The moon's face cooled completely, its molten heart shrinking until only a small metallic core remained. Occasionally, even now, the moon trembles. Small moonquakes, caused by the slow contraction of its crust or the distant pull of Earth's gravity. They are faint reminders that it is not entirely dead. The surface hardened into permanence. Without air or water, erosion could not soften it. The oldest craters, more than 4 billion years old, are still sharp. When meteoroids strike, they throw up dust, a fine powder of crushed glass called regolith. Each grain carries history, fragments of basalt, traces of ancient solar wind, the scars of cosmic rays. Apollo astronauts later found that this dust clings to everything, sharp as ash, scented faintly of gunpowder. The moon's steady orbit stabilized the Earth's tilt at 23.5 degrees, the angle that gives us seasons. Without that anchor, the planet's axis might have wobbled wildly, sending climates into chaos. The moon's presence made Earth habitable in the long run. It is a quiet architect of life. When the last volcano dimmed and the final seas of lava cooled, the solar system grew calm. The moon, once a blazing ember, became a lantern. The Earth turned blue beneath it, its oceans rising and falling in a gentle breath. And from that moment onward, the two worlds have moved together, one alive, one silent, in a dance older than memory. Every crater on the moon is a memory, a record of collision written in stone and silence. Unlike Earth, where wind and rain erase the scars of time, the moon remembers everything. Each impact that ever struck its surface is still there, frozen in light and shadow. Across its face lie millions of craters, from tiny pockmarks no wider than your hand to enormous basins, hundreds of kilometers across. The largest of them, the South Pole, Aten Basin, stretches more than 2,500 kilometers, nearly a quarter of the moon's diameter, and plunges 8 kilometers deep. It was likely formed by a colossal impact more than 4 billion years ago, when the solar system was young and full of wandering debris. These impacts were unimaginably violent. When a meteor hit, its energy vaporized rock, melting crust into glass and throwing dust halfway across the moon. Rays of bright material, like the ones that radiate from the crater Tycho, spread outward for hundreds of miles. The smallest craters overlap the older ones, creating a landscape layered in time. If you were to walk across it, every step would cross millions of years. On Earth, we see erosion as a sign of life. Wind, water, movement. On the Moon, stillness is eternity. Its airless surface holds a perfect record of its own past. Each crater is both wound and monument, a quiet mark of survival. Between the Great Plains and the dark seas rise mountains that are not the result of tectonic uplift, but of impacts. When the ancient asteroid basins formed, the crust around them buckled upward, creating ranges that curve along the rims of old wounds. The Montes Apenninus, the Montes Alpis, the Montes Carpatus, names given by early astronomers gazing through small telescopes, are not the product of slow continental drift, but of sudden celestial violence. These mountains are vast. The Apennine Range, for instance, stretches over 600 kilometers, peaks rising 5,000 meters above the surrounding plains, higher than the Alps on Earth, yet they are utterly silent. No wind carves them. No river flows between them. Their slopes are dust and shadow, sculpted only by the light of the sun. From orbit, astronauts describe the landscape as frozen motion, a world paused in mid-breath. The shadows at lunar dawn creep slowly across the summits, revealing ridges and valleys that have not changed in billions of years. Some peaks are sharp and bright, their surfaces composed of reflective anorthosite. Others are dark and weathered by countless micrometeorite impacts. To look upon these mountains is to see time itself made solid, the geometry of ancient violence transformed into beauty. The great dark patches, visible from Earth, the Maria, are among the most striking features of the Moon. For centuries, people believed they were literal seas, imagining the Moon as a mirror of Earth, complete with oceans and islands. Only later did we learn the truth. They are frozen floodplains of lava, the remains of immense volcanic eruptions billions of years old. The Maria cover about 16% of the Moon's surface, concentrated mostly on the side facing Earth. When giant impacts cracked the crust during the Imbrian period, magma from the Moon's interior welled up to fill the basins. The molten rock spread in vast sheets, cooling slowly into dark basalt. Iron and titanium within the lava made it denser and less reflective, giving the Moon its characteristic two-toned face. Each mare tells a story. Mare Imbrium, the Sea of Rains, formed when a colossal asteroid struck and created one of the largest basins in the solar system. Mare Tranquillitatis, the Sea of Tranquility, where Apollo 11 landed, preserves smooth plains of ancient lava, nearly 3.5 billion years old. Mare Serenitatis and Mare Crisium shimmer with subtle color differences that reveal varying compositions of minerals, like ilmenite and pyroxene. When you look up at the Moon and trace its dark patches, you are seeing the ghosts of oceans that never were, seas of stone that once flowed like fire and then froze into eternity. Covering every surface of the Moon is a layer of fine gray dust called regolith, a mixture of crushed rock, glass, and metal fragments. It is the product of billions of years of impacts, each strike grinding the crust into smaller and smaller pieces. The top few centimeters are soft as ash, but beneath that lies a layer compacted by time, dense enough to preserve the footprints of astronauts for millions of years. When Apollo astronauts first walked upon it, they found that it clung to their suits, sharp and gritty. Some said it smelled faintly like spent gunpowder, a scent born not from burning, but from the reaction of lunar minerals with Earth's oxygen when the dust was brought inside their spacecraft. Each grain is jagged, untouched by the erosion that rounds earthly sand. Under a microscope, lunar dust looks like shards of glass, angular, crystalline, and full of microscopic craters of its own. The regolith records everything. In its upper layers lie tiny beads of glass formed from micrometeorite impacts. Deeper down, particles of solar wind are trapped within mineral grains, offering clues to the history of the sun itself. The dust is a cosmic archive, a silent library of radiation, impacts, and ages long gone. When you picture the moon's surface, imagine not emptiness, but layers of memory, a soft blanket woven from the debris of time. For most of human history, half of the moon was invisible to us. The same face always turned toward Earth, locked in what astronomers call tidal locking. The far side, sometimes mistakenly called the dark side, remained hidden until 1959, when the Soviet spacecraft Luna 3 captured the first blurry images. What those images revealed was startling. A landscape far more rugged than the familiar near side, covered with mountains and craters, and almost entirely lacking in the dark Maria. Scientists believe this difference arose because the crust on the far side is thicker, making it harder for lava to reach the surface. The near side, facing the warmth of Earth, cooled more slowly and allowed volcanic plains to form. The far side remained colder, its crust sealing early. The largest structure on the far side is the South Pole Aitken Basin, a vast scar from one of the earliest impacts in solar system history. It exposes material from deep within the moon's mantle, a glimpse into its hidden interior. In recent decades, orbiters, like NASA's Lunar Reconnaissance Orbiter and China's Chang'e missions, have mapped the region in detail, revealing valleys, peaks, and a permanent twilight where the sun barely grazes the horizon. Though invisible to our eyes from Earth, the far side is as much the moon as the one we know, colder, older, and untouched by the gaze of humanity for almost all of history. Its silence completes the story, one half familiar, one half forever remote. Though the space between Earth and moon seems vast, it is never empty. An invisible thread binds the two: gravity, silent and unbroken. Every atom on Earth feels its pull. The oceans rise and fall in answer to its call. Even the solid ground flexes slightly as the moon passes overhead. When the moon first formed, it was perhaps 10 times closer than it is now. The gravitational pull was immense, drawing up tides so high they raced across the continents like slow-motion tsunamis. That motion, repeated day after day, transferred energy from Earth's rotation into the moon's orbit, causing the Earth to spin more slowly while pushing the moon gradually outward. Even today, that process continues. The moon drifts away at about 3.8 centimeters per year, the width of a human thumb. Sensitive lasers, reflected off mirrors left by the Apollo astronauts, measure that drift precisely. It is the quiet ticking of the solar system's clock. If you could see gravity itself, you would see a shimmering web connecting the two worlds. Earth pulling the moon pulling back, both circling a single point of balance, the barycenter, about 4,700 kilometers from Earth's center. The two never stop moving, never stop responding. It is a conversation in silence, a dialogue in motion. The tides are the Earth's heartbeat, driven by the moon's invisible hand. Twice each day, the ocean rises and falls, a planetary breath drawn by gravity. When the moon's pull lifts the water on one side of the globe, another tide forms on the opposite side, caused by inertia as the Earth rotates beneath. The result is a ceaseless rhythm, the most ancient of all rhythms, the sound of the planet breathing. These tides shape the coastlines, feed the estuaries, and keep the oceans alive. In the shallows, nutrients rise and fall, feeding coral reefs and plankton blooms. In the deep, currents generated by tides help mix the global waters, distributing heat and oxygen. Without the moon, Earth's oceans would stagnate. Life might never have spread beyond the sea. Tides also influence the Earth's rotation, slowing it by fractions of a second each century. That deceleration lengthens our days and pushes the moon farther away, in a feedback loop that has lasted since the beginning. Ancient corals reveal that hundreds of millions of years ago, a year contained more than 400 days, each day only 22 hours long. The corals grew in daily layers, tiny ridges of calcium marking each sunrise and tide, preserving the rhythm of a faster Earth. To listen to the waves at night is to hear the voice of gravity, the soft translation of cosmic motion into sound. Every ripple, every crash is a whisper from the moon. The moon is moving away. Year after year, millimeter by millimeter, it drifts outward along its orbit. It is a slow, graceful motion, too small to notice, yet vast in its consequence. In about 600 million years, the total solar eclipses we know will no longer occur. The moon will appear smaller in the sky, unable to cover the sun's disk completely. The perfect alignment we now witness is temporary, a brief coincidence in cosmic history. The drifting moon also tells us the age of the Earth moon system. By measuring its rate of recession and modeling backward through time, astronomers estimate that the collision with Theia occurred about 4.5 billion years ago. The Apollo missions confirmed this through radiometric dating. Lunar rocks, collected from the Mare Imbrium and the highlands, are ancient, 3.1 to 4.4 billion years old, older than nearly any rock on Earth. The outward motion of the moon subtly changes the Earth's tides and lengthens our days. Over eons, that will slow the planet until one day, far in the future, Earth and Moon will face each other eternally, both tidally locked, one hemisphere of Earth in perpetual moonlight, the other in darkness. By then, the sun itself will be entering its final age. The dance will end, but only because the music of the solar system will have changed. The drift of the moon is not a retreat. It is a rhythm, a slow exhale written into the geometry of space and time. The moon always shows us the same face. This is not coincidence, but consequence. The result of tidal locking, a balance reached over millions of years. As the moon's rotation slowed due to Earth's gravity, it eventually matched the time it takes to orbit once around us. Now, it turns just fast enough to keep one hemisphere facing Earth forever. Because of this, we see the same markings each night: the familiar eyes and mouth of the man in the moon, or the rabbit seen by East Asian cultures. The far side, hidden from our sight, remains mysterious even now. Older, more cratered, more silent. The difference between the two halves is a story of heat and history. The near side's crust is thinner, shaped by ancient lava flows, while the far side's crust is thick, sealed by cold. Through this perfect equilibrium, the moon has become a mirror of consistency. Every tide, every cycle, every night's reflection exists because of that balance. The same stability that gives us gentle seasons also grants us the calmness of a predictable sky. There is a lesson in that motion and stillness are not opposites. The moon moves endlessly, yet its face never changes. It reminds us that constancy can live within change, that to turn in harmony is to remain whole. If you could drift far enough into space to see the Earth and Moon together, you would see a pair in motion, two bodies circling a shared center of gravity, orbiting the sun as one. They are partners, not parent and child. Each moves in response to the other's pull. The Earth gives the moon its brightness, reflecting sunlight onto its surface. The moon gives the Earth its rhythm, pulling the tides and steadying its axis. Their relationship is one of exchange, energy for stability, light for time. It is a cosmic duet, played out across the silence of 384,000 kilometers. From the surface of the moon, the Earth never rises or sets. It hangs motionless in the black sky, glowing blue and white. Astronauts who have seen it from that vantage describe an overwhelming sense of fragility, a realization that everything we are exists within that delicate sphere. They call it the overview effect, a shift in perception that blurs the boundaries between nations, between self and world. The Earth and Moon together form a single expression of gravity's art, balance through motion, harmony through distance. Without one, the other would be incomplete, and in their reflection, we find a quiet metaphor for connection itself. How even in separation, two things can move together as one. Every night, the moon changes. It grows, fades, and vanishes, only to return again. A rhythm older than life. The phases of the moon are caused by geometry. As the moon orbits Earth, sunlight strikes it from different angles, and we see the changing portions of its illuminated half. Yet for all its simplicity, this cycle has been one of humanity's greatest teachers. Of time, of renewal, of patience. From new moon to full, about 29.5 days pass, the length of a synodic month. The crescent rises after sunset, glowing fragile in the western sky. As nights pass, the curve widens, the light strengthening until it becomes whole. The full moon, bright enough to cast shadows and silver the ocean's skin. Then the light recedes, shrinking again to darkness. Long before calendars, the moon's phases were how humans measured time. The very word month comes from moon. Farmers planted and harvested by its light. Sailors navigated tides by its pull. And poets measured the cycle of longing and release in its glow. Astronomers now understand that the lunar phases are not only visual, but physical. The moon's orbit is slightly tilted, causing subtle variations in brightness and color. The full moon is never perfectly full. Its light shifts with each orbit, with the dust in the air, with the eyes that watch it, and still, each month, it returns. Proof that in all change, there is repetition. And in repetition, peace. Sometimes, the sun, earth, and moon align so precisely that shadow itself becomes spectacle. When the earth moves directly between the sun and moon, our planet casts its shadow upon that gray surface, a lunar eclipse. For a few hours, the moon darkens, glowing copper red, as sunlight bends through the Earth's atmosphere, scattering blue light and letting only the deep crimson of dawn and dusk reach it. To ancient people, this was a moment of awe and terror. They thought monsters devoured the moon, or gods hid it in their anger. Today we know it as celestial geometry, a perfect alignment of three bodies across 400,000 kilometers of space. A solar eclipse is the inverse. The moon passes between Earth and Sun, casting a shadow upon us. Though the Sun is 400 times larger than the moon, it is also about 400 times farther away, a coincidence so precise that the two appear the same size in our sky. During a total solar eclipse, day becomes night, the air cools, animals fall silent, and for a few fleeting minutes, the stars return. Then, as the sun's light bursts around the moon's edge, the corona shines, the sun's outer atmosphere, visible only in these rare moments. These alignments remind us how delicate and temporary cosmic order can be. Millions of years from now, as the moon drifts farther away, total eclipses will cease. The geometry will unravel. What we witness now is a rare moment in the life of the universe, a perfect accident of distance and light. The moon always faces us with the same side, but it has another half, one that no human saw until the middle of the 20th century. The far side, revealed by the Soviet spacecraft Luna 3 in 1959, astonished the world. It was rugged, pocked with craters, and almost completely devoid of the dark basalt plains we see from Earth. Scientists soon learned why. The moon's crust is thicker on the far side, up to 60 kilometers compared to 30 on the near side, which prevented magma from reaching the surface. The near side, warmed slightly by Earth's gravity and radiation, remained geologically active longer, allowing lava to fill its great basins and form the familiar Maria. Later missions, NASA's lunar orbiter, Clementine, and the Chinese Chang'e probes, mapped every valley and ridge in exquisite detail. They revealed the massive South Pole, Aten Basin, one of the largest impact craters in the solar system, and permanently shadowed regions where sunlight has not touched for billions of years. In these deep craters, frozen water ice lies preserved, hinting that one day, humans might return and drink from the moon's ancient cold. To look at the far side is to look at mystery itself. It reminds us that what we see is never the whole, that every familiar face hides a hidden world. The moon turns endlessly, yet its secret half remains forever just out of view. At first glance, the moon appears white, but through a telescope, its true colors emerge: subtle grays, silvers, and ochres, traces of blue in the young basalt, brown in the highlands, faint gold where the sunlight glances low. The color we see depends not only on its minerals, but on the air we breathe. During a full moon, sunlight reflects off fine dust on the surface, rich in minerals like ilmenite, olivine, and pyroxene. The reflected light is nearly colorless, what scientists call neutral gray, but Earth's atmosphere scatters shorter wavelengths, lending the moon a warmer tone. When it hangs low on the horizon, we see it through thicker air. Dust and pollution filter the blue, turning it amber or orange. Then there are the blue moons. Not truly blue, but rare events when two full moons appear in a single calendar month, or when volcanic dust in the atmosphere gives the moon a ghostly hue, and the blood moon of an eclipse, painted red by the bending of sunlight through our skies, when every dawn and dusk on Earth converge on the moon at once. Each variation tells a story about connection, how the moon's light must cross our world before it reaches our eyes, carrying the fingerprint of our own air and dust. Even its color is a collaboration, half lunar, half terrestrial. The moon, in every shade, is a portrait of the space between worlds. For billions of years, the moon has not only shaped Earth's tides, but life itself. In the deep ocean, corals release their eggs in perfect synchrony with the full moon. Sea turtles crawl ashore under its light to lay their nests, guided by its silver glow. Even tiny plankton rise toward the surface when moonlight shines through the waves. On land, nocturnal animals time their hunts and migrations to the moon's brightness. Studies show that some predators, like lions and owls, hunt less on full moon nights when prey can see them more easily. Others, like insects and seabirds, navigate by the lunar light reflected on water. Humans are no exception. Our sleep cycles subtly shift with the lunar month. During the full moon, people tend to fall asleep later, sleep less deeply, and wake more often. An echo of ancient biology, tuned to light and darkness. Hormones like melatonin follow patterns shaped by those same rhythms, even in cities bright with artificial light. The moon's presence in our sky is more than beauty. It is biology. Its light flows through ecosystems, directing migrations, spawning, flowering, and even the beating of human hearts. It is a cosmic metronome, keeping time for every living thing that listens. Before science gave us equations and data, we had stories. The moon, glowing through the ages, became our oldest myth, the lantern of gods, the face of spirits, the measure of time. Every civilization looked upward and found meaning in that light. In ancient Egypt, the moon was Khonsu, the traveler, god of time, who crossed the heavens nightly. The Greeks called it Selene, a goddess crowned in silver, driving her chariot of light. To the Romans, it was Luna, giver of calm and clarity. In China, the moon was home to Chang, who drank the elixir of immortality and floated skyward, leaving her lover on Earth. The Mayans imagined it as Ixchel, weaver of life and rain, her cycles controlling fertility and water. Even in prehistory, the moon's rhythm guided ritual. Paleolithic carvings on bone, found in Europe and Africa, mark the lunar cycle, tallying nights long before calendars. Farmers sowed and harvested by its light. Travelers used it to find direction. Lovers swore oaths beneath its glow. To dream of the moon was to dream of continuity, a promise that no matter how the world changed, that light would return. Across millennia, through empires and ruins, the same light touched every human face that ever looked up and wondered. When humans began to paint, carve, and sing, the moon became muse. It appears on ancient pottery, woven into textiles, carved into temples aligned to its rising. Later, in the age of telescopes and ink, artists tried to capture its surface, the delicate shading, the deep shadows, the luminous calm. In the 17th century, Galileo Galilei pointed his telescope upward and saw mountains and craters, proving that the moon was a world, not a perfect celestial sphere. His sketches, rough but revolutionary, changed how humanity saw the sky. Centuries later, Vincent van Gogh painted it as a living pulse in the starry night, spiraling through thick, dreaming color. Claude Debussy gave it sound in Clair de Lune, Light of the Moon, a melody so soft, it feels lunar itself. Writers have followed its glow too. In the verses of Li Bai, in ancient China, the moon is a mirror of longing. In Shakespeare, a witness to love and madness. In haiku, it is a pause. In modern poetry, reflection and solitude. Even cinema carried its fascination. From Georges Méliès's 1902 classic Le Voyage dans la Lune, with its whimsical rocket landing in a lunar eye, to the solemn realism of Apollo 13. Across every art, the moon is constant. It invites imagination without end. Its mystery is fertile ground. The moon does not explain itself. It allows us to dream upon it. Humanity's curiosity grew into machinery. In 1959, the Soviet Luna 2 became the first human-made object to touch the moon, crashing into its surface and scattering emblems of Earth. That same year, Luna 3 sent back the first photos of the far side, grainy, miraculous, the unseen made real. By the 1960s, a race unfolded, not one of war, but of wonder. The United States launched the Apollo program, immense rockets, each a mountain of fire and calculation. In July 1969, Apollo 11 touched down on the Sea of Tranquility. Neil Armstrong stepped from the lunar module and spoke words that echoed through the static of space. That's one small step for man, one giant leap for mankind. For the first time, a living being stood on another world. The footprints remain, preserved in dust where no wind will ever erase them. Subsequent missions, Apollo 12 through 17, brought back 382 kilograms of rock and soil, revealing the moon's chemistry: basalts rich in iron, anorthosites from the highlands, glass spherules from ancient impacts. They told the story of a body old beyond imagining. 4.5 billion years of silence held in stone. Those missions ended, but the journey never did. In the 21st century, new explorers returned. Orbiters from India, Japan, China, Europe. Rovers mapped the poles, seeking ice in shadowed craters. Humanity had left its mark, but also found humility. The moon is not conquered, it is known, and still it waits. The moon is drifting away, a slow, silent departure written into the laws of motion. Each year, it retreats another few centimeters. Over millions of years, the tides will weaken, days will lengthen, and the Earth will turn a little more slowly. The bond remains, but the dance evolves. Scientists measure this drift using laser reflectors left by Apollo astronauts. They send beams of light across space, and each one returns 2.5 seconds later, the time it takes for light to cross the void twice. The changes they record are minute, but relentless. The moon is exhaling, expanding its orbit, changing the rhythm of our world. Yet even as it recedes, it holds us in balance. Its gravity stabilizes the Earth's tilt, keeps our seasons mild, and our climate steady. Without it, the planet might wobble like a top, swinging through extremes of ice and heat. The moon, in its distance, is still our guardian. This slow retreat is not an ending, but a continuation. The universe does not cling, it flows. Everything moves outward. Galaxies, stars, even the atoms in your body. The moon reminds us that separation is part of harmony, that love, gravity, and time all express themselves through motion. The moon lives not just in the sky, but in us. It rules our inner tides, the pull between rest and wakefulness, calm and reflection. Even in sleep, our brains respond to its rhythm. Studies show that during full moons, human sleep becomes lighter, dreams more vivid, cycles of hormone and mood subtly shift. The body remembers what the mind has forgotten, that we evolve beneath this light. Artists and mystics have long connected the moon with emotion, intuition, and imagination. Its soft illumination invites introspection. Its cycles mirror the phases of feeling, waxing with hope, waning with release. Ancient healers saw it as the mirror of the soul, the place where memory and emotion dwell. Psychologically, the moon is projection, an empty mirror that reflects whatever we bring to it. We see loneliness, beauty, eternity, all in a single white disk. To some, it means peace. To others, melancholy. Yet every meaning is true. The moon accepts all and judges none. In dreams, it often appears as a guide, a beacon across darkness, a symbol of return. It reminds us that what feels distant may still be part of us, that light can exist even where there is no fire. When you close your eyes tonight, imagine that light, not above you but within you, a quiet radiance that asks nothing, shines everywhere, and waits. Now the journey draws to its end. The earth turns once more beneath the silver gaze of its oldest companion. The moon hangs steady, unmoving, though it circles endlessly through space. Its light touches every ocean, every mountain, every sleeping form. From the first collision to the first dream, from fire to memory, the moon has never left our side. It steadied our world, measured our time, guided our stories, and reflected our imagination. It is the bridge between motion and silence, between matter and meaning. When you look up, you see not just rock, but history, the fire that birthed it, the tides it raised, the eyes that loved it. You see yourself, reflected in its calm. The same dust that coats its plains lies in your bones. The same elements that shine in its light burn in your blood. You are not separate from the moon. You are its echo, its continuation, its living dream. And now, as you rest, the night deepens, the light softens, the world exhales. The moon keeps watch, patient and eternal. Sleep comes easily beneath its glow. Good night, traveler under the silver sky. The moon remembers you,